Hello children, welcome to my channel. The first chapter for standard 10 is real numbers. So this is part 1. The topic that you are going to learn in this chapter is the LCM and HCF, which you have already learned in your smaller classes. So LCM is the full form is least common multiple, and HCF means it is highest common factor. So you have learned how to find the LCM. So this is a normal way that you find LCM. You will divide it with the common factor, and then 4 3 times is there, so 4 cube, then 3 square, and then 5. So the total the product is 2880. So what exactly it means? This LCM, this is multiple. That means this number will be exactly divisible by each of these numbers. 2880 divided by 144, you will get it as 20. This LCM divided by 180, it's 16, and LCM divided by 192, it is 15. So it is completely divisible. Now coming to highest common factor, that is HCF. That is, for example, we'll take the two numbers 24 and 12. Factors of 12, it is 1, 2, 3, 4, 6 and 12. And for 24, it is 1, 2, 3, 6, 8, 12 and 24. So the name suggests common factor. So let us see what are the common factors. 1, 1, 2, 2, 3, 3, then you have 6 and 6. Then 12 and 12. So many common factors are there. But we need the highest common factor. So the highest among these factors are 12. Is 12. So the highest common factor, the answer is 12. Now we will learn to find HCF and LCM using prime factorization method. So prime factorization method, first you have to write it as product of prime. One prime number, as you know, it is that it will have only the number and 1 as a factor. So 144 can be written as 2 to the power of 4. Normally you divide, you will get 2 to the power of 4 into 3 square. 180 will be 2 squared into 3 squared into 5, and 192 is 2 to the power of 6 into 3. Now to find the HCF, that is, it is a common factor. So we will see which are the common factors. Now 2 to the power of 4, 2 square and 2 to the power of 6. Out of this, 2 squared is the common factor. So 2 squared, and then 3 squared and 3. So 3 is a common factor. And 5 is there only in 180. It is not there in the other two numbers. So you will not consider 5. Only which is common to all the three numbers you have to take. So it is 2 squared into 3 equal to 12. So the same answer you got with this method also, 12. So the rule is factor should be there in all the numbers, and the least exponent of the common factor should be considered. Now to find the LCM, here you have to consider all the factors. Whether it is common or not, you don't have to worry. All the factors you will consider. So 2 to the power of 4, 2 square and 2 to the power of 6. Now you will take the highest exponent. So 2 to the power of 6. Then 3 squared, 3. So 3 squared. And then 5 is there only in this number. Still, you should take 5. So if you multiply, you will get 2880. That's what you get with this method also. So the all factors should be considered. It need not be common, and the highest exponent of the common factor has to be taken. So when we do the application problem, we will be dealing with application problems related to LCM and HCF. So when we do there, you will understand this method much better. The next important property that you are learning is product of two numbers is equal to HCF and product of HCF and LCM of the numbers. So these questions come in your MCQs. So HCF is 145 and LCM is 2175 is given, and one of the number is 725 is given. So find the other. So let that the other number be A. So A into 725 is equal to 145 into 2175. So A equal to, divide it, you will get 435. The next question. Can two numbers have 16 as their HCF and 380 as their LCM? Give reasons. So HCF and LCM, what is the connection between HCF and LCM? HCF will be a factor of the LCM. So it is, HCF is common factor and LCM is a common multiple. So it has to be, HCF is a factor of LCM. That means it should be completely divisible. So now let us try 380 divided by 16. It is not divisible completely. You are getting 12 as a remainder. So the numbers cannot have 16 as the HCF and 380 as the LCM. Another important property that you are learning is fundamental theorem of arithmetic. Short form is FTA. So the theorem says every composite number can be expressed or factorized as a product of primes, and this factorization is unique. This is very important, unique, except for the order in which the prime factors occur. So we will take an example, 48. So you can write 48 in various ways as 2 into 24, 12 into 4, 16 into 3. But 24 is a composite number, 12 is a composite number, 16, 8 into 6. So let us write, we have to write it as a product of primes. So when you write it as product of primes, 48 is 2 cube into 2 into 3. That means 2 to the power of 4 into 3. 2 to the power of 4 is 16. 16 into 3, 48. So you have to first express it as product of primes. So once you express in product of primes, this is the only way this number can be expressed. That's what it is. It means it is unique except for the order in which the prime factors occur. Instead of this, you can even write it as 3 into 2 to the power of 4. Only the order matters. A into B or 3 into 4 or 4 into 3, the answer is same. So based on this, there is a question here. This question also comes for your 2 markers. Prove that there is no natural number for which 4 to the power of n ends with digit 0. You have to give the reason also for this. So 4 to the power of n can be written as 4 can be written as 2 squared to the power of n. So that is 2 to the power of 2n. You have to write by uniqueness of FTA. This is the only way of expressing 4 to the power of n. Now we have to see what is a digit number, unit number, that is, it is ending with whether it ends with 0 or not. So in the units place, whether it can end with 0 is what we have to see. For that, for any number to end with 0, it should have 2 and 5 as factors. If you see, for example, 20. 20 is 4 into 5 or 2 squared into 5. 30. You have to express everything as product of primes. 30 is 2 into 3 into 5. 50 is 5 squared into 2. 70 is 7 into 5 into 2. What do you observe common in this? You have 2 and 5 as factors. 2 and 5. 2 and 5. You can have other factors, but compulsorily you should have 2 and 5 as factors. Then if you have that, automatically 5 into 2, 10. Into the remaining numbers, so it will definitely end with 0 only. So you have to write that reason. For any number to end with 0, it should have 2 and 5 as factors. 4 to the power of n does not have 5 as a factor, hence it cannot end with 0. You have to write specifically by uniqueness of FTA. This is very important. Show that 12 to the power of n cannot end with digit 0 or 5 for any natural number n. So earlier we did only for 0. Now we have to find for 0 also and for 5 also. So again we'll write 12 as product of primes. 12 is 4 into 3. 4 is 2 squared into 3, the whole to the power of n. So it is 2 to the power of 2n into 3 to the power of n. Again you will write it as uniqueness of FTA. So now to end, the number to end with 0, you should have 2 and 5 as factors, which we saw in the previous problem. So 2 and 5 are compulsory. For a number to end with 5, factor 5 should be there, but 2 should not be there. Because if 2 and 5 is there, then it will end in 0. So to end with 5, it should not have 2, but it should have 5. For example, 25 if you take, it is 5 square. 35, 7 into 5. 45, 3 squared, 9 into 5, 3 squared into 5. So any number to end with 5, it should have definitely 5 as a factor, but it should not have 2 as a factor. So 12 to the power of n does not have 5 as a factor. Hence, it cannot end with 0. It has 2, but it does not have 5. So it cannot end with 0. Also, it does not have 5 as a factor, but it has 2 as factor. Hence, it cannot end with 5 also. Now, another type of question which comes for your exam is, explain why this is a composite number. So, as I told earlier, number is prime only if it has 1 and the number as factors. Now, we will write this number simplified. We will take 7. 7 is common. This is one term. 3 into 5 into 7 is one term. So, we will take 7 out. Then you are left with 3 into 5 is 15. Plus 7 has been taken out, so we are left with 1. So 16. 16 can be written as 2 to the power of 4. So this has other factors 7 and 2. Hence, the given number has 2 and 7 as factors. Hence, it is composite number. So I'll see you again with the next topic in my next video. So keep practicing. The more you practice, you will become comfortable. We will do a lot of application problems also related to LCM and HCF. So till then, have a great day.